So simplify. Most of you can probably reduce the 45 over 360 in your heads. Not that I expect you to be great at fractions. Of course, two ways you can do them on your calculator. You can do 45 divided by 360. That's going to kick out the decimal answer. It says no decimals. So you can hit math on the left side, enter, enter. And that will convert it into fraction for you. So I want the 1/8. Now, another way you can do it, and I can't say one way is faster than another. The other way you can do it, if you hit alpha y equals, it pulls up your fraction bar for you. So now I can type it in literally just how it looked, and I don't have to do the math, enter, enter. I don't know if one is less keystrokes than the other, but I just wanted to show you that way too. Now, no decimals, my friends. So first, I'm going to do this 120 over 360, but I know some of you should do that in your head. I'm going to show you the alpha y equals way, just something different here, 120 over 360. I'm sure most of you are doing that in your head, I hope, maybe. So you have 1/3 for that. Now, final answer, remember, says no decimals. If you're like, I hope you can do 1/3 times 9 in your head, please tell me you can. What's 1/3 times 9? 3. If you're like, oh, I'm awful at fractions, we'll just now hit times 9, and it will give you the 3. Now, let's talk about the pi. So, because really, what is pi approximately? 3.14, and it says no decimals in the directions, so I'm going to leave it as pi in the problem. I'm not going to use 3.14, I'm just going to leave it as 3 pi for the answer. All right, number 3 should be short and sweet, like me. What's 15 over 3? So 5 over 1, which I would just leave as 5, so final answer, I'm going to put 5 pi. Okay, just to be fancy, I'm going to do this one by hand, because I can reduce 60 over 360 in my head. 60 goes into itself once, 60 goes into 360 how many times? 6. Now, we have to do times 15, of course, but I can reduce that in my head. What goes into both 6 and 15? 3. 3 goes into there twice, 3 goes into there 5 times. So I have 1 times 5 on top, or 5 pi, and 2 on the bottom. Again, you can use your calculator to get the 5 over 2. I'm not judging your fraction work. Well, maybe a little bit. But we should be able to do most of this in our heads, if we can. All right, but up to you guys how you want to do them. So take a look at this one. Now, this is a review question from Chapter 10. Number 5 is from Chapter 10. We're using this skill today. A central angle of a circle. I'm even feeling generous. I'll draw a picture today. So there's my circle. Central angle is a vertex on the center, is 82. What is the arc? 82. They are the same. We have to use that skill today. Now, my other question, and I know you know the answers to these, but just review from Chapter 10 for me, because it's going to come into play today. A full circle is how many degrees? 360. Half a circle is 180. So keep those skills in the back of your head. Now, today, this is getting you ready for our arc length formula, which I haven't even talked about yet. But if you just look at it, you have the 2 fractions set equal, 2 ratios set equal. So just like we went over proportions, I forget, last week or whenever, I'm going to use cross products. So again, I'm going to use my calculator. I'm going to do 3.8 times 360. You're going to straight punch that in, of course. And then your other diagonal is x times 120. So of course, to get x by itself, you wouldn't even have to necessarily write that. You could do this all in your calculator. To get x by yourself, you know you got to divide off the 120. All right, so punch that in. That one will give you a decimal. I rounded to the 10th for whatever that's worth.
11.
I like it. I'm running out of room, so I put the answer up here for you. So just some review, how to do some fraction work in your calculator, etc. I'm just looking around to see what we have for calculators. I think most of us have graphing. If you have a scientific, there is usually on them a button that will simplify the fractions for you. If you don't know where it's at on your scientific calculator, I can come around at the end and I'll show you, okay? So 2 things we're working on today. Circumference, which you should know, and then we're going to do the new one, arc length. Now, other things from Chapter 10 that are coming back into play today. You have to know the difference between a radius and a diameter. Do you? What's the relationship between radius and diameter? Alex? It's twice the radius. So diameter is 2 the radii. Diameter goes all the way across, edge to edge, hits the center. Radius is half that amount. So that is why there's 2 formulas here for circumference. 2 radii make up 1 diameter, just for the record. Okay, so what is circumference, of course? The circumference of a circle is the distance. The words in red are what you have to fill in on your notes. The distance around the circle. For all circles, the ratio of the circumference to the diameter is the same. This ratio is known as pi. So let me give you a minute to fill in the words, and I'm going to just kind of explain that a little bit. So let's talk about pi for a second. I know we all know it's about 3.14, but let's talk about really where the calculations come from. It's not just something some old math dude made up to torture math students. If you take any circle, like my clock, if you have a circular watch, if you have a big circle, I don't care the size of the circle. If every single time you divide the circumference by the diameter, every single time, regardless of the size of the circle, you end up with approximately 3.14, or pi. That is where the calculation comes from. It's not just some made up random fact, my friends. Now, formula for circumference, that's what we're going to fill in next. It's on the board over there in purple. You're going to fill it in here. So circumference, of course, you can do pi times diameter, or 2 times pi times the radius. So it just depends on what they give you. So fill those in on the blanks. It's in purple too, same stuff. Now it just depends on what they give me, what I'm going to use for the formula. If they give me the blue, mine's in blue, yours isn't obviously. If they give you the blue diameter, I'm going to do pi times diameter. If they give me the red radius, 2 pi radius. Now, if they give you the diameter, can you still use 2 pi r? Yeah, just recognize, you know it, you told me, that the radius is half of a diameter, so you can still do that. Now, let's talk about this. This isn't on your note sheet, we're just going to talk about it. I'm going to show you where it's at on your calculator. We should be using the pi key, not 3.14, because you want this to be as accurate as you can possibly get it. So if you're on a graphing calculator, just to make sure we know where pi is, if you look, it's kind of above this, what we call the caret key on the right-hand side. So if you hit second and the caret key, it will pull up, it will use all the decimals that can fit in the screen for pi. So I'm going to be using that button today, not 3.14, just for the record. All right, let's practice some circumference calculations first, and we'll get into that arc length formula. So find the indicated measure. They want the circumference with a radius of 9. Now, since they give me the radius, I'm going to use this one, the 2 pi r. So I'm going to do 2 times pi times r. Now, I'm going to punch that into my calculator. Okay, I'm not going to do it by hand, obviously. And I'm going to even make it less work for myself, because I can do 2 times 9 in my head. So I'm going to do 18 pi. Probably the quickest way to punch it in. Doesn't say what to round to. I'm just going to go to the 10th then. So I'm going to put 56.5. I'm going to label it at centimeters. So the entire distance around the circle. We're going to simplify that in a minute. Radius of a circle with circumference 26. So this time they give you the C. They tell you what it should equal. You're finding the radius. So this time, of course, I'm going to use the 2 pi r form. And you're going to solve for the radius, or I should say we're going to solve. Now, to get the radius by itself in one step, how do you get rid of the 2 pi? Divide it. Now, one thing we got to be careful in our calculators. I know 26 over 2 is 13, and you can make it 13 if you want. If you want to just straight type that in your calculator, be careful. Because if I just do divided by 2 and then I hit pi, it's going to mess up your order of operations. I'm going to put parentheses. I want it to divide by both the 2 and the pi. So I had some kids last hour that weren't using parentheses and getting different numbers. That's why. It's only dividing by 2, then it's technically timesing by pi. So if you're going to do it all in one step, which I do, I just put parentheses around the 2 and the pi, so it does it all for me, and I don't have to worry about it. I'm just going to round to the 10th here. That's a 4, a sloppy 4. 4.1 meters. All right, circumference of a circle, diameter 5 inches. Okay, all right, I got it. This time I'm going to use the pi d version because they give you the diameter. So I'm going to do pi times diameter. And of course, you know that's times between them, so just punch that right into your calculator. And again, I rounded to the 10th. They looked at it there, 15.7. And I'm going to throw a label on, we're in inches. So scan over the first page of your notes here. We're going to do a couple more circumference on the next page, but any questions on circumference on the front side so far? Anybody? Okay, so one more circumference problem, and then we're going to get into that arc length. So dimensions of a car, tire, or show. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So 15 times around. Ooh, well, let's first start with just one time around. Let's just get the circumference of the tire. Now, I'm looking at my circumference here. What formula do I want to use? Well, I don't see the radius on there, but I think I can get you the diameter. Because remember, the diameter goes all the way through. So the diameter is going to be all of this. So I'm going to mental math it. 5.5, 5.5, that's 11. What's 11 plus 15? 26. So I've got a, I can't write and talk, I've got a diameter, D, that was going to be a sloppy looking D, of 26. So when I do my circumference, I'm going to do the pi D, pi times 26. Just for fun, humor me. If the diameter is 26, what would be the radius?
81.
Radius.
You're right.
13. Alex is already shooting out the circumference for me. 81.7. I'm going to label, feeling fancy. Now, that was pretty easy. That wasn't too stressful. But we got to keep reading this. To the nearest foot, it's interesting. How far does it take for 50? So one time around is 81.7. How are you going to get 15 times around? Times 15. Okay, punch that in for me. Round to the 10. And this is the never-ending problem, my friends. And this would be a good standardized test practice problem. To the nearest foot, we are in inches. So we got to convert. How many inches in 1 foot? 12. So now I'm going to divide by 12 to get it converted into feet.
102.18.
Around to whatever, I don't care.
1.8.
Oh, 0.2. I thought 1.8. Sorry, Alex. 102.1, right?
Yeah.
There we go. Got it. Okay. So I don't want you to be like, holy cow, that was a truckload of stuff. And it kind of was, but it really wasn't. We had to do circumference, which we've been doing, one time around. They wanted 15 times around, super exciting. And then they wanted to the nearest foot, so I just had to convert. That's as wild as it would be on any circumference questions on the homework today. So any questions, circumference or radius? All right, let's talk arc length. So first, before I get into that formula that's kind of in that dark pink color over there, arc length is basically you are finding just a piece of the circumference. Maybe we just want this little piece here. You're only finding part of the distance around the outside edge. So that's why that formula is a little bit more complicated. So you need to fill in, of course, on your notes what's in red there. Arc length is a portion of the circumference of the circle. So write what's in red. Now here's the bad part of this. The formula obviously is a little more involved because it's a portion, aka a fraction, everybody's favorite. That's why you can see there's these two fractions over here. It is a fraction. The arc length is part of the circumference. You're comparing it to the overall circumference. I'm going to click the slide. This is on the next one. And then, of course, our angle measurement, angle, central angle, vertex on the center, over the full circle, 360. Because we are doing part or portions or fractions of the circle now, not the whole darn thing. So arc length, here's the formula for you to fill in. So write that in on your notes. I'll give you a minute for that. And you can see it's a smidge different than what I have on the board. We'll talk about the block. remember it is a portion or a fraction of the circumference. That's why we have all the fractions. Now, like I said, it's a little different than what I have on the board up here, because on the board, I don't have this. I have C. Well, why? Isn't this the circumference? 2 pi r is the circumference. I was just too lazy to write that on the board. Okay, so circumference. So there's all sorts of different things they might ask you today. So we have to be super conscientious of this formula and what all this stuff means. 360, always 360. That's never going to change today in your formula. That is a fixed number. These other three, depending on what they ask you, can change, okay? So circumference, of course, that's what this is. If I need circumference, we're finding C. Arc length. Now the arc length, remember, I wish we had color copy machines, of course, is the portion of the circumference. Notice these look kind of similar, so you have to keep these numerators straight in your head. The arc length, the first numerator, is the portion of the circumference. This measure of AB is this angle here in degrees. So that's the angle, the central angle portion. Okay, so that's what you have to kind of keep straight, of course, are the numerators. Arc length is part of the circumference. The second numerator is the central angle measurement, just for the record. Because, and that makes sense to me, we're doing part of the full circle, which is 360. We're doing a fraction of the full circle. That's why that's what the 360. So let's do it. I wish we had color copy machines. Yours clearly aren't in red. You might want to bold in or signify what we're finding up here, because unfortunately, I don't have color copy machines. So we are finding the red arc. Okay, I'm on it. So of course I'm using my arc length formula, the two fractions, fixed measure. This is always 360. Don't even think about it, it's just 360. Got it. Now, what are we finding? It wants you to find the length of the red arc. So we need this piece. I'm just going to call it X. That's what I'm going to find. Okay. Bottom. I can get you this. The circumference. Well, they give you the radius. So I'm going to do 2 pi r. And we can punch that in our calculator. Clearly, I'm just setting it up.
50.3.
So maybe you might already have it. Now, this numerator. This numerator, remember, is the angle in degrees, your central angle, which of course, 60. Now I know you can reduce and calculate some of that. I'm even too lazy for that. I just go straight to my calculator and let it do all of the work for me. Because of course I'm going to do cross products. So the first thing I do is I type this. That scared me. First thing I do is type this yucko, all of this in my calculator. I normally don't even write times 60. I don't have no idea. I usually just do times 60. So you can type that all in your calculator and hit equal. Your other diagonal, of course, x times 360. Now, we know this. How are you going to get x alone? You divide by what? 360. So I generally don't even write this. I just punch this all directly into my calculator. So do your 2 pi times 8 times 60, and then divide by 360. And I rounded to, for whatever it's worth, to the 10th. So half the battle, okay, is punching these in your calculator correctly. So I want you to practice typing these in. Because every year, I swear, some poor kid sets up every single thing perfect in the formula, but something happens on the calculations. So try the calculations, make sure you can get it. You should get, and I can punch it in if you need me to do it, you should get 8.4. How'd we do?
I got it.
Okay. And I'm going to put the final answer over here because I'm running out of room. And I'm happy to pull up the calculator and type it in if you need me to. Sure. So I'm going to do 2 pi, and then what did I have? Times 8 times 60. So there's that answer. And then I just hit divided by 360. Enter. Come on. There you go. And I just rounded it. All right, let's try B. Now, same thing. I'm going to set up my two fractions set equal. I know this is always 360. I don't even question it, okay? So let's see what we all have here. They want me to find the arc length. So this is what I'm after. I'm going to call that x. That's the first numerator. Now, bottom, of course, the circumference. Well, I see they give you the radius, So I can do circumference 2 pi r. And you can just put that in your calculator and get the value for it. I don't care. I'm just setting it up for you. And then, of course, our other numerator is our central angle measurement, 120. 120 degrees, part of the full circle. Now from here, I'll be honest, I generally don't write anything else. I just go to my calculator. Because I'm like, all right, I'm not doing this by hand. I punch this guy in my calculator. 2 times pi times 11 times 120. And then you know to get x alone, divide by 360. I'm going to write it out for you guys. I'm feeling generous today. And then I just punch it in. Now again, practice, this is a skill all on its own. Practice punching that in to make sure you get the correct answer. Yeah, I rounded this one to the whole. You should get 23 centimeters. So anybody need me to type that one in on the calculator? I'm happy to do it. You just know how slow I type on that thing, so nobody really needs to witness it. Okay, let's try the next. It's going to change a little bit. Formula's the same, but notice they want circumference. Before I get stressed, I'm just going to write out my fractions here. I know that's always 360. Okay, let's see what we got here. So this time they give you the arc length. Okay, cool. Got it. I'm on it. And you have your central angle. That's the second numerator, so 40. Got it. And this time they want you to find the circumference. Now, of course, 2 pi r is on your note sheet. I have C out on the board over there because 2 pi r is the circumference. So this is our equation we're going to solve. Still, I'm on my calculator now. So I'm going to do 4.19 times 360.
Would circumference be in inches?
Yes, sir. And then my other diagonal, C times 40. And I know you know to get C by itself, you're going to divide off 40. All right, doesn't say what to round to, so I went to the 10th, round to whatever, surprise me, I don't care. Punch it in and see what you get. I like it. And I'm going to put inches on. I got it. Anybody need any help with the calculator part of that? So that is the tricky part, of course, knowing what you're solving for, because now it's changing a little bit. Even this one's a little different. Okay, before I even get crazy, I'm just going to set up my fractions. We know that's 360. Okay. I always start with the easy, obvious stuff, okay? Find the measure of arc RS. Okay, arc S. Now, this is a throwback to chapter 10. This is why I love geometry. I'm going to highlight RS, but I'm like, oh, crud. Am I doing the top arc or the bottom one?
Bottom one.
The bottom one, because 2 letters to name an arc makes it minor. You have to be less than 180, just for the record. Now, they gave you the arc length of that. They tell you it's 44. Okay? It is a portion of the circumference. Now, I can get you the circumference because they give you the radius here of the circle. So I'm going to do my 2 pi r. So the arc length is a portion of the circumference. Now, they want us to find the measure. The only thing left to fill in, they want the angle. So I'm going to use that as my x there. All right, cross products. So I've got 44 times 360. This one I am going to show you how to punch in to make sure we got it, because you have to divide by a lot of stuff. But 28x. So we all know to get x alone, you're going to divide the 2 pi and the 15.28. Now, let me pull up the calculator because I'm going to give you the same spiel as I did on a similar one. I'm going to do the, let's clear this, the 44 times 360. But when I go to do my dividing piece, what am I putting around the 2 pi 15.28? Parentheses. Otherwise, it only divides by 2, then it times by pi, yada, yada, yada. So divided by, I want to divide by 2, I want to divide by pi, I want it to divide by 15.28. Got it. And I'm going to, let's just round that. I'm going to go to 165 for it. Sounds like a winner to me. And remember, that's the angle, the portion of the full circle. Just for the record. Hit it, Alex.
I've been evaluating the 2 pi at 15.
That's fine. So it might round your answer a little differently. Fine. I don't care. Nope, that's totally fine. That's why I always tell kids, always show me your setup, because if your answer is a little different, I just assume it's a rounding difference, and I don't care. I'm not going to be upset about it. All right, find the circumference. Now, I'm like, holy cow, which formula am I using? I'm thinking, oh, circumference, 2 pi r. I don't have the radius, nor do I have the diameter. Credola, I got to work off that arc length one. Okay, all right. So I got to work off the fractions. We always know this bottom right's 360, that never changes. So let's see what they give us here, what we can fill in. Find the circumference. Well, that's the bottom, the first denominator, that's what I'm after. The top, of course, is the arc length. The second numerator is the angle, central angle. So what goes where is my question. Is the 270 first or second? Second. And notice the degrees always line up. They always stay with each other. And then, of course, this is my arc length, the 61.26. And shockaroo, we're going to use cross products. Oh, God. All right, so from here you can mostly use your calculator. So 360 times 61.26. And I know you know you're going to divide off 270. All right, I'll give you a second to punch that in. What do you got?
81.60.
I like it. Whatever you round to, if you did 0.7, great, I don't care. Meters. And same thing too, like on a quiz, test, your homework, whatever. Do I need to see this middle part that I have written in blue? No, because I know a lot of you can just use your calculators and do the cross products fine. Very minimum for work, I need the setup and the final answer, obviously. You can do all the calculator stuff, I don't need to see it. All right, find the radius. Oh, okay, all right. So I'm looking at what they gave me. Arc length, central angle. So I'm going to have to use the fractions. Okay. Since they gave you arc length and central angle. Of course, this is always 360. Let's fill that in. Now, I've kind of been giving some of this away. They gave me the arc length, the 10.5. That's the first numerator. Central angle is your second. So clearly, I'm finding this bottom, or the circumference, or 2 pi r, or whatever you want to put in there right now. Now, since they're asking you for the radius, I'm going to put in the 2 pi r. Now, shockaroo, cross products. I know you didn't see that coming, did you? So I'm going to do in my calculator 10.5 times 360. This is a whole lot of stuff. I've got 150 times 2 pi r. Now, we can still do this majority work in my calculator because they want the radius. So to get rid of the 150, the 2, and the pi, we got to divide all of that off. 150 and the 2 pi. Now, be careful. In your calculator, what do you have to put around the 150 and the 2 pi? Parentheses. So take a second, well maybe more than a second because that's a lot to punch in, and type that in the calculator. For whatever reason, I rounded this one to the whole unit. You round to whatever.
Oh yeah, this one.
Yeah. And if you need me to type it in, of course I will. You should get a relatively small number. That makes you feel any better.
No.
All right, you should end up with 4 feet.
Can you do that in the calculator?
Yep, I was just going to ask, do we need to punch that guy in? So I'm going to do the 10.5 times 360 first. 360, got it. So there's the numerator. Then I'm going to do divided by and throw my parentheses on this. Now, 150 times 2, I can't say as I'd really type that in because really, what's 150 times 2? So I'm going to put 300 pi. Just a little less keystrokes for it. Might help if I actually hit enter. And when you round it, I just rounded it to 4 feet. Okay. Let me look at it when we're done, Gabby, for you. Because that's half the battle, I feel like, typing these guys in, okay? All right, final one. Now, I love it. When we read it, it's going to ask you to find the length of the red track. Clearly, your notes are not in color, so maybe bold in the red track part. So here we go. The curves at the ends of the track shown are 180-degree arcs of the circles. Now, why is that important? I'm going to stop reading for a second. 180 degrees is how much of a circle? Half. So we have 2 half circles here on the ends. 2 half circles makes 1 full circle. 2 half circles makes 1 whole circle. Right, a little mental math. Gabby, I'll look at that for you when we're done. Let's get our last word problem under control here. So the radius of the arc for the runner on the red path is shown, yada yada. About how far does the runner travel to go once around the track? So you, my friends, and I know it would be nice if you had colored notes, are finding the red track here. So you might want to just bold that in on your note sheet so you can see it, so you know what the heck you're finding. Now, distance around. So the 2 ends, remember, we have the 2 half circles, aka 2 half circles makes 1 full circle. So if you just put these 2 ends together, if I smush the ends together, you'd have 1 full circle. I need the circumference of that circle, so I have the distance around the curves on the end. Well, am I using 2 pi r pi d? Clearly, if you read it or look at the picture, they give you the radius. So I'm going to do 2 pi r, and the radius is over there, 36.8. All right, first start with that. Type it in. What do you got? So much calculator. So 231.2, I like it. Now, let's remember, that is just the ends here. I'm trying to bold them in, I don't know how well that's working. That's just the ends. It wants the full track, so we need the straightaways. Well, don't overthink it. Look at the picture. It's on the picture. How far, what's the distance of the straightaways? Yeah, and we've got 2 of those. So I've got the top straightaway and the bottom straightaway. Type that, add those together, and that will give you the overall length of the track that the little guy's running around. Yeah, let's just round it. Let's make it easy. Let's put down what? 400 sounds good.
That's the standard.
It pretty much is. All right, so any questions on that problem? That was it for that guy. Now, so on your homework, let me give you a hint. Like, I'm looking at that top part, the 11 through 16 part. Clearly, you have a way better, oh my gosh, that's a horrible circle. You have a way better picture than what I'm drawing you. Clearly. Okay. Well,
That's pretty good.
I kind of fell in on that side there. Okay, here's the thing. If this is 40 degrees and it tells you in the directions, and I don't have it labeled, it's labeled on yours prettier, angle ADC, so this bottom one, it says is congruent to this guy. You're going to need those measurements. You can find those measurements, because a full circle is what?
No,
360. And if this little piece is 40,
The rest is 320.
the rest is 320, and these 2 it tells you are congruent.
160.
So they're each going to be 160. So you're going to need that little tidbit of information on the homework. Now also, read 11 through 16 close. Some of them, 13, 14, 16, want you to find the arc length. So this Crazo formula. Notice like 11, it wants the measure of arc A, I'm going to do it in green. Yours is labeled prettier. A, C, B. I can find you that arc with no work. What's ACB? 320, 160, 160, 320, I'm done. Bam, 11, done. So some of them are that easy. They're just asking you for the angle measure that equals the arc. You don't have to do a whole lot of craziness. Where it says the word length, that's where you have to use your formula. So